Well, welcome to Rebel Book Club. Thank you so much for joining us. From where are you this morning?
Thank you so much for having me.
Where are you joining us from?
I am joining from Copenhagen.
I'm joining from where you live and study.
Yes, I'm doing my PhD, so I'm actually at the lab right now, setting up an experiment, and then had a little bit of waiting time to chat with you.
Well, tell us briefly what your experiment is in your PhD.
I'm doing like what you broadly would call aging research. I'm focusing on something called extracellular vesicles. So the experiment I'm doing right now is being in the lab with some muscle and some fat cells, trying to do some interesting stuff there.
In the lab with muscle and fat cells, fantastic. So you're living your work every day. Well, we've really enjoyed reading Jellyfish Aged Backwards at Rebel Book Club this month. It was voted by our members who are watching this now to be the book that they wanted to read on this topic. And I guess I had to start by asking you, Nicklas, is like, what does your morning routine look like now you're an expert in longevity? Have you been up for 5 hours already?
No, I am naturally like a morning type person, so that definitely helps. But I would say my everyday life is quite hectic these years because I'm doing the book stuff and I'm doing the PhD, and so I mean my morning routine is not particularly interesting. It's getting up rather early, getting a high protein, high fiber breakfast, of course, taking a shower, stuff like that. And then I usually go here, try to tackle the biggest task of the day in the beginning when you know cognitive energy levels are high, and then taking.
So you eat the frog.
I eat the frog.
That's one of the phrases for saying you tackle the hardest task.
Oh yeah.
Early in the day, because it's the ugly one, right? You have to eat the frog.
Definitely find that to be the best approach. I don't know if it's whether it's because I'm a morning type person or whether that's universal, but at least for me, my energy levels are highest in the morning, and then I just try, in the afternoon, it's the simple tasks that just need a bit of routine or something like that.
That makes sense. So coming to the book, your book Jellyfish Aged Backwards, take us back to the moment where you decided this topic and actually your core insight, which is we can learn from nature about our own health and potential lengthening our lives by protecting or slowing down the disrepair of our cells. When did this become an important focus for you?
Well, it's actually Jellyfish Aged Backwards is actually the first book in a trilogy of science books that I'm writing. So I kind of had the idea for all of them simultaneously, and then I decided this one is the best one to start out with, but more on the way. But definitely, what is interesting is that if you look into society right now, we have all these different diseases. It's pretty much the same in all of the developed world. Sometimes the leading cause of death is cancer, like it is in Denmark. In some other countries, it's cardiovascular diseases, but these are the two major groups. Then you also have stuff like dementia, which is also a big cause of mortality. And of course, then if you're in an environment like I am right now, there's a lot of research into each specific, not just disease category, but they dive into each different sub-disease. And we try to cure them, and sometimes it goes well, sometimes it doesn't. The problem is, however, that even if you cure someone of a type of cancer or a type of cardiovascular disease, the main cause still is there, because the main cause is aging. So someone my age, I'm 29, I just don't get dementia, for instance. I have an extremely low risk of getting a cardiovascular disease, and I'm protected against most types of cancer. But the older I get, the higher my risk of these various diseases. So if we just cure the disease, it's not enough to cure the underlying cause, so to say. So if we really want to make inroads, we want to find out what is causing the aging process in the first place, and then try to slow down that.
Exactly, that's a great summary. And so, of course, you focus on nature, and your great example you begin with is jellyfish and how they're able to repair their cells, or at least slow down the process of them degrading. Was there, when you started your study for this first of your 3 books, was there a moment where you said, oh, okay, my big assumption here that I'm testing or researching is actually potentially true. And what was that moment? Was it with the jellyfish, or was it another creature? When did it become really exciting?
Yeah, so just to address the point from before, yeah, it's when you then have you're standing in front of a big issue in biology, the best first step to take always pretty much is to look into nature and get some ideas about what's possible. For instance, if you are a physicist, there will be certain laws of the universe that you can, lean on, and you can say beforehand a lot of the times whether something is possible or whether it isn't. When it comes to biology, of course, biological creatures have to obey those laws, but we don't always know what is possible beforehand because biology is just that much more convoluted. So it makes sense to just look out into nature, of course, also look out on other humans and then say, what can we find there? So it might be that aging is this, thing that nature has just put in place that just cannot in any way be tackled. And we would learn that if we look into nature. And we just don't see any long-lived animals. For instance, if humans were the longest-lived animals, it doesn't imply that tackling aging is impossible, but it would at least make it clear that it will be very, very hard. But if we actually do look into nature, we see all these animals like the Greenland shark or the bowhead whale that live much longer than humans. So we can at least say, okay, we don't know whether biologically it would be possible to be immortal, but even in animals like the bowhead whale that are pretty similar to a human, we can see that they can live at least twice as long as the longest lived humans. So there is at least some room there. That could be the first goal, then to try tracing this lifespan. Then if we look at other animals like the jellyfish, or I look at salmon, you can look at lobsters, there's all these different patterns of aging as well. So it's not just that lifespan can have certain different lengths. There's also different ways to get from point A to point B, which is in the old age. Because if we look at the various animals, old age does tend to look similar in a lot of species. So if you look at an old dog, it has, like a human, has gray hair, it has lost muscle mass, bone mass, lower immune function. It has all these different things that is similar to what we experience. It just gets there faster. But then with the pattern of aging, we also see that in humans, there's this, gradual decline. It's not something you feel from day to day, but it catches up on you eventually. But then you have animals like the salmon or other animals that age with similarity, where you don't really have physical decline until the very end of life, and then it just goes down really steeply. So kind of like if a human had the body of a 25-year-old until the day they turned 90 and then aged in a month or two from there. Then we have the lobster that doesn't age at all. We have the jellyfish, of course, the Turritopsis dorni, which can age backwards. So we see that animals can live longer and they can also age in different patterns. And that's just really encouraging to then start digging into the details, because that shows it's not like a fool's errand. It's not something that is impossible before we even start. It is possible. It's still going to be hard, but then at least we know that it's a task that can be accomplished.
It's really well explained. I love the examples and comparisons, and imagining what it's like to be feel and look like a 25-year-old when you're 90 is crazy. So now the book's been out, I think, for coming up to 3 years, right? And what's been the response? What's been the journey since then? And I guess also in terms of cellular science, the work you're doing and other scientists are doing, biologists are doing, have we seen any big jumps forward? Because the story around this longevity and feels like it's grown a lot in recent years.
Yeah. So actually, when I first wrote this book here in Denmark, I tried to make a list of all the publishers that could potentially be interested, and I started just being ambitious, starting from the top, and it was literally rejected by every single major publisher in Denmark. There was not a single one. Some of them rejected it twice because I was a little stubborn and didn't accept the no's. And I was actually very close to, I was in talks with my parents to borrow some money and then just self-publishing it, because I just couldn't find anyone who was willing to give it a shot. Then finally I found my publisher here in Denmark, like one publisher who was willing to give it a go, a small publisher. And then after that, it has just been completely crazy. So we sold out before the book even had been published. It was the most selling book, or at least non-fiction book in the country for at least 1 year, I think, in perhaps for two years. It has now been translated into 30 different languages around the world. And then, of course, the whole thing culminated in the UK, actually, because it was nominated for Science Book of the Year by the Royal Society. So it's been a great ride since then, but it actually took me a longer time to find a publisher here in Denmark than to write the first Danish draft of the book initially. But since then, the response has just been overwhelmingly like a great experience. I get messages from all around the world from people who have read the book, and it's out from India to Brazil to the US.
That's amazing, Nicklas. And your persistence is definitely paid off. And why do you think this resonates? Because obviously humans have always been interested in living longer, right? This is not a new idea. Why do you, and there's a lot being written on this, why do you think when you're having these conversations with all these different people and communities, what is it about this approach that you're taking that's resonating? And are we seeing progress even since then on the research around cellular repair?
Yeah. So we definitely see progress in the research, and we see also importantly progress in the funding, especially in Silicon Valley. A lot of big tech people have decided to invest. I don't think there's many of the big tech billionaires that doesn't have some kind of financial investment in these areas now. I wouldn't say, I mean, there's definitely been progress since the book came out. I'm not sure there's been progress that is proportional to the interest and the
right. So the interest graph is like this, and it's a bit steadier.
I'm also, that's also one of the things that I have been you're right that there's a lot of writing on this topic. A lot from the United States as well. And I think one of the things that has helped this book stand out and also gather attention is probably also that I try to do a more, I don't know if I would call it European approach, or there's definitely a lot of hype in this area. And some of the hype is true. Some of it is, one person hypes to this level, and then to get attention, you have to hype to this level, and then it just spirals.
And then we have the Brian Johnson story, and exactly.
Exactly. It's not that there's no value from some of this, but I also think it is, we shouldn't tell this story in a way where people are like, oh, okay, this is done, you see all this interest and the science, I'm just going to lean back and just wait for this to eventually just happen by itself. We're definitely having some good progress in the funding and stuff, but scientifically, we are at the very, very beginning. There's so much about aging we don't know, even very fundamental stuff. We don't even agree yet why aging happens. Like I described in the book, we have different theories, and that's okay. But definitely, we need a lot more to be done. And it's not like we are 5 years away from immortality or whatever you can sometimes read on Twitter and stuff like that.
Well, what's interesting is that this is your note at the end with Copenhagen 2022. You say, provided we can continue our progress in medical science, there's no doubt we will eventually defeat aging. This is a bold statement, Nicklas. The question is when, whether it's 50, 500, 5,000 years. So,
and that's just the important part is if you just look at medical science, we haven't slowed down and we keep conquering disease after disease, but it does go very, very slowly. Back in the 70s, in the US, they launched the war on cancer. And since then, we have definitely decreased the death rate for cancer. We know a lot about how to prevent it, but people still die from cancer. A lot of the people who signed that document are probably dead, part of them from cancer.
Yeah.
So we have progress. We also have progress in living longer, but I would of course like a world where when I'm older and I sit back, we have made progress maybe to the point where we have actually defeated this, and not sit there and say, okay, I still believe we're going to defeat it, but it just didn't come in my lifetime.
Yeah. Well, you've started early in your life, and you're playing a big part, so you're doing everything you can. So one historical question, then forward-looking question these come from our members. Looking backwards, one of the big insights that I think has jumped out to us is this shift from saying genes are responsible for how we age and how we die, to lifestyle being the dominant factor. In your research and understanding, when did that tip? And is it now accepted, do you think, in scientific circles, that it's lifestyle over genetics that are the dominant reason for our health span and lifespan?
Well, it's lifestyle compared to genetics in our current environment. I think it's important to note, because we could envision some crazy genetic engineering in the future that could definitely tip the balance, so that you would, to this day already, we know various mutations that a few lucky people have that can make you practically immune to cardiovascular diseases, or practically immune to dementia. And then suddenly lifestyle wouldn't matter so much, because then a large part of the lifestyle component would be removed. But definitely by now, it has sort of been a slow build-up where when we try to determine what the genetics behind a trait is, there's studies like twin studies, where you try to look at identical twins, and usually they're so much alike because they have the same genetics, so they look alike, they have the same height, they have a lot of the times the same interest, but lifespan-wise, they don't tend to be so alike. And then in the last 2 decades especially, there's been these big studies where people have looked into, for instance, online genealogy databases, and tried to look like how similar are people actually in their lifespan within families. And just the better the method, the lower the genetic component turns out to be. So I don't know if there's rarely, that single study that just makes everyone throw away all their results and just say, okay, now this is it. But it's just been slowly building up. And we do also see this huge interest in then going to what is it then about lifestyle that is so important.
And a massive industry around it. And what's interesting, isn't it, around that kind of, maybe it's a gentler shift, but certainly that shift in that direction, is it goes from a fate-minded approach to living, which is okay, this is how it is, this is what I got served, these are my cards, to I can control a lot of this, not all of this. And I think that's what's so fascinating, because that has a massive impact on society. And sort of looking forward now, do you see this new wave? And yes, a lot of it, as you said, especially in the US, is clearly hype, but that brings the money, which accelerates the research, as you said. But do you see, which areas do you think are really interesting in terms of how people are trying to use control stressors maybe more in their life? The explosion in exercise and endurance racing is something I'm very tuned into. Obviously diets and so on as well, social life. What are the areas that you think are really interesting where people are sort of focusing on?
Well, it depends whether it's like the science, or it's the more lifestyle component. Because in the science, the most interesting areas, in my opinion, not to discount anything, because it's clearly still really good that we have studies in which exact exercise, which exact diet, but I think we have a lot of you could call it maybe the skeleton ready, so that we can kind of see where to go there. Whereas in the pure hardcore aging science, there's still so much more that we need to find out. And I think some of the high-tech solutions are really interesting. So if you would draw a parallel, right? I'm Danish, so Novo Nordisk, who made Ozempic, is Danish as well. And that obviously takes up a lot of like mind space in Danish science, but there you have like finally they cracked the code and you have a pill and you can then at least help people lose weight. And of course, if we could make that to that point in aging research, that would be a drastic shift, where so some of this like fine-tuning exercise and diet would also be very nice, but getting to the point where you can go somewhere and you can get a treatment that just extends your lifespan, even if it's just a little bit, or something that you can do that is not a lot of effort but has a big impact, and that's of course something we can only get from like the pure aging science, like doing experiment on cells, mice, and eventually humans.
And we're still in science fiction world there, aren't we? Because you think of all those utopian, dystopian films around this stuff that have led to those ideas of like the magic, the pill that makes you last forever. And tell us briefly as we wrap up, Nicklas, about the trilogy. So, well, two questions really. You mentioned some of the heroes in the book: the Greenland shark, the bow whale, of course the jellyfish. Maybe give us one more. For those who haven't finished the book, one more of your favorite examples from nature around aging, and then tell us about the next, if you can, what comes next in your trilogy.
Yes. So there's so many cool animals to start from here. I would say one of them is the naked mole rat that you almost have to mention when you talk about aging science, because a lot of science is done in rats and mice, and that's true of aging science as well. And rats and mice will live, they're very lucky, maybe 2.5 years, maybe 3 years. We know already a lot of ways to extend the lifespan of a mouse or a rat, but the problem is sometimes humans already live so much longer. So likely some of the ways we can extend the life of a mouse is already inbuilt, like it's already inbuilt in our biology, so it won't help a human. But then what's really interesting is that usually small animals like a mouse and a rat do live quite short lives, but then the naked mole rat, which is like the same size as a mouse, can live way longer, at least 35 to 40 years. It has all kinds of weird aspects of its biology, like being better to survive at low oxygen levels, having a weird social life, being very resistant to cancer, and has all these things that makes it really interesting to then say, okay, here we have two animals that are related, the mouse and the naked mole rat. One lives way longer, like 10 times longer at least, is resistant to cancer, which kills 70% of lab mice. So then trying to dive in to the comparative biology and saying, what is it that is so much better about this animal? And could we then maybe find some mechanisms that we could take and then apply to humans to get some of the same effect? I would say that is kind of like the darling of the aging community right now.
Not the most beautiful, but the most
definitely not the most beautiful, but almost so ugly that there's some kind of beauty hiding there, because it's it goes all the way around and loops around, and has such a big has such a special biology that is really something distinct when it comes to aging.
Yes.
Yeah. And then for the other question, so my second book, which is called Super Stimulated, it comes out in English in June, I believe.
Oh, great.
We're just doing the final touches right now. It's already out in Denmark. It's also already out in the Netherlands, in Norway, and in Germany. And we have a lot of languages coming as well, like Spanish, Portuguese, French. Oh, it's also out in Italian recently. It just came out in Italian as well. So there's a lot coming there. And just the synopsis in the book is basically, in the first book, we talk about all these diseases that are due to aging. That's part of what plagues society with ill health. But we also have a lot of issues in modern life, health-wise, that are not related to aging. So we have the obesity epidemic, we have record levels of loneliness, we have a lot of problems with mental health, especially among young people. We have an increase in various forms of addictions, all the way from the really bad ones, so stuff like the opioid epidemic in the US, to just being addicted to your smartphone and having a really hard time cutting down on your screen time. And again, it turns out that just like with cancer, dementia, and heart disease, there's this underlying phenomenon that that is a cause of all these health problems at once. So they might seem distinct, but there's actually this underlying issue, which is what is called a superstimuli, and that's what I dive into in the second book. Talk about everything from like ultra processed foods, how they have made the obesity crisis, how the rise of digital living, so spending all our time on social media, Netflix, computer games, how that has driven a lot of like the social dysfunction we see, how various companies are speculating in earning money from hacking our biology just in the wrong way, figuring out how the human reward system works and just pressing it so hard that people have a really hard time controlling their behavior. So that's the second book.
Super stimulated sounds brilliant, Nicklas. That's exciting. We'll look out for that in the UK and beyond in the coming months. But thank you so much. I really hope that this recording of our brief conversation today, as well, of course, your book, will last until 2100 when we can meet again.
Definitely hope so. And if not, then for the second book in a little bit of a short time.
It's coming a bit quicker than that. And good luck with the muscle cellular lab work today. And thank you so much for your brilliant book and your time.
Thank you so much.
Awesome.